All right, so far we've mostly just focused on one variable linear equations. I'm going to show you and talk about the rationale there, and I'm going to talk about these power equations and radical equations. Generally, after this, we'll get into standard forms of quadratic equations and using the quadratic formula to solve those. So first, just remember, when we're solving an equation, the entire goal is to perform the opposite operations that are being performed on the variable in the opposite order. And I just want to remind you of that and then show how that translates to these examples and other more complicated examples. My variable x is being multiplied by 2 and then 5 is being added to it. So what I'm first going to do is subtract 5 from both sides of the equation. The action of subtracting 5 undoes the addition of 5 that's going on right here. So what I'll now have is 2x equals 8. And then we know what we want to do is, since our variable is being multiplied by 2, we're going to divide by 2 to undo the multiplication by 2, resulting in the value of our equation, or our variable, being x equals 4. Okay, so the only question we need to answer, it's the same concept for these two equations. The question we need to answer is, what is the opposite of the operations being performed on the variable? And here we actually have those two separate operations, inverse operations happening. In this equation, our variable is being squared, and in this equation, our variable is being square rooted. In both cases, we're going to do the opposite of what's happening. The opposite of squaring is square rooting. So I'll rewrite it here and show this. I'm going to square root both sides of this equation. The result of square rooting undoes the squaring. They're inverse operations of each other. And what I get here is x. The square root of 25 is 5. There is a small issue when I apply an even root radical. That's a general statement, but what we need to focus on in this class are more of square roots. If I apply a square root to both sides of an equation, I need to add a plus minus, and I'll talk about why in half a second here. I get a plus minus. What this means mathematically are two different answers. X equals 5 and x equals negative 5. If you think about going back to the original equation, x squared equals 25, both 5 and negative 5 are valid answers because when I square 5, I get 25. And when I square negative 5, I also get 25 out because the negative 5 times negative 5, the negatives cancel, resulting in 25. So there's a small little trick. When I apply a square root, I have to bring in a plus minus to get the positive and negative versions of the solution. Okay, let's now talk about radical equations. I'm going to do the same but the opposite thing here. My variable is being square rooted, so what I'm going to do is I'm going to square both sides of the equation. Importantly, I always square all of both sides when I do this. And there's things we need to do to manipulate the equation so it works out how we want to. We'll get to that in the next example. But when I square this side of the equation, the squaring action undoes or reverses the square rooting. What I get here is just x. And on this side, I get 9. Importantly, and this can always be a little bit confusing, when I add the square root to review, I get this plus minus to get 2 answers. But when I square, I don't get 2 answers, I only get 1. There are a couple different reasons for this. One thing that will occur with more complicated equations is I square, I might make fake or extraneous solutions. We're not going to cover that in this video or in this section right now, but it's something to be aware of. In this version, I need to create more answers than the actual square rooting gives me. Sometimes when I square an equation, I get fake or extraneous solutions that I need to account for. Let's now look at a little bit more complicated versions of the squaring and the square rooting. All right, now we have a bit more complicated power equations or quadratic equation and a radical equation, square root equation over here. I'm going to walk through these. What you're going to see is the first steps are very, very similar to a linear equation until it comes time to deal with the square or the square root. And then we need to remember when we square root to get rid of the squaring over here, we get this plus minus. And when we square, we don't have that going on. Okay, first and foremost, my operations going on here, I'm subtracting 4 from x, then I'm squaring, then I'm multiplying by 5, and I'm adding 7 last. So the first thing I'm going to do is subtract 7 from both sides of the equation. What that does on the left-hand side is undoes the plus 7. So I'll get 5 times x minus 4 squared equals 245. Now what I'm going to do, because of this operation multiplication on the outside here, I'm going to divide by 5 next. That gets rid of my multiplication of 5. And over here, 245 divided by 5 is 49. All right, now comes the time to deal with the squaring. I am now going to square root both sides of this equation. That will get rid of the square here. It's going to turn this 49 into a 7, but I can't forget that plus minus that we talked about a second ago. So I'm going to square root. That square rooting gets rid of the square, and I'll have just x minus 4. And on this side, on the right-hand side, what I'll have is plus or minus 7. Now, I'm not done with answering this question. This is a really important piece right here. This is actually 2 separate equations right now in how it's written. And I'm going to write those out and solve them individually to get my 2 answers. And I do expect 2 answers, by the way. This is a quadratic equation, and I'm expecting 2 unique answers. I can have just one, or I might have no solutions, but very often we get 2 solutions. And just a little hint, if I have an exponent of 3, I could have 3 unique solutions, but we're not dealing with that now. To get my 2 solutions, I create my 2 equations. One is x minus 4 equals 7, and the other is x minus 4 equals negative 7. I add 4 to both sides to get x equals 11, and over here, I'm going to get x equals negative 3 when I add 4. Both of those are valid solutions to that original equation. Okay, now this square root equation, I'm going to do the same thing. I'm first going to take care of the operations outside of the radical and then square to get rid of the square root. So I'm first going to add 5 to both sides of the equation, giving me 3 times the square root of x minus 4 equals 15. Now I'm going to divide both sides by 3. That takes care of the multiplication of 3 over here, leaving me with the square root of x minus 4 equals 5. Now, I'm going to take care of the square root by squaring both sides, giving me the result of x minus 4. Again, now there's no square root around it. The square cancel with the square root equals 25. I'm simply going to add 4 to both sides now to get my final answer for this equation of x equals 29. And I can't emphasize enough, the one difference between these two is this resulted in 2 solutions when I square rooted. When I'm squaring, I'm using the squaring or exponent of 2 to both sides, I do not get 2 solutions from that. And in fact, if I was going to be completely mathematically accurate and safe, what I would need to do is check this solution in the original equation, which you could do on your own. It is the solution and it does work. All right, now we're going to talk about solving standard form quadratic equations. These are equations that look like this. These are the first of many more complicated polynomial equations. Here we have the quadratic formula. This is a formula that solves this just by solving this expression right here. And I'll talk about this real fast. First of all, the solutions to ax squared plus bx plus c equals 0 are found with this formula right here, which is x equals negative b plus or minus. You might recognize the plus minus from taking the square root earlier. It's the same plus or minus, by the way. Square root of b squared minus 4ac all over 2a. It looks complicated, but when you actually get to use it, it's not as complicated as it seems. A, B, and C are just numbers. That's really, really important. They're the coefficients of this equation right here. Before I go any further, I just want to say why we have this maybe slightly complicated formula for doing this is there's no way of using normal linear kind of tricks or stuff we've just learned previously like square rooting. The important reason for that is because we have our variable in two different terms and there's no way to add, subtract, multiply, divide, square root to isolate that variable. So we have more advanced techniques. This is one. We have factoring is a really popular version, and completing the square is another popular version of solving quadratics like this. So first of all, I'm going to identify these letters A, B, and C. Again, they are the coefficients of the equation. It's very important to note, though, before I can do this, my equation needs to be set equal to 0. So one side is 0, and my other side has all of their beautiful terms going on there. Once I've done that, I can identify A is the lead coefficient here, which is 6. B is the 2, this linear coefficient next to the x right here. And C is what we call the constant coefficient, and C in this case is a negative 20. Just to clarify there again, right, this subtraction I read as a negative. The sign of the term, whether it's plus or minus, goes along with these coefficients. Okay, now what I'm going to do are to put those numbers, again, without any variables, into this expression over here, the quadratic formula. So I get x equals negative b, so b is 2, negative 2 plus or minus. The first thing under the square root is b squared. I like to actually square it when I put it in there. So b squared would be 4 minus 4 times a, which is 6, times c, which is the negative 20. All over 2 times my a value of 6. Okay, and then to evaluate this, I first need to evaluate this expression inside. Don't forget that multiplication happens first. Most modern calculators will allow you to input this string right here. I did that a second ago. My calculator told me that 4 minus 4 times 6 times 20 gives me 484. So I have 484 under the square root, all over 12. Now what I'm going to do is take the square root of 484. I'll talk in other videos about what to do if this is not a perfect square and square roots nicely. There's ways that we work around it, and we talk about whether giving exact solutions or approximate solutions. But here we are. I've done most of the work. What I'm going to do now is I'm going to give myself some room, and I'm going to show how I get my two solutions from this expression right here of negative 2 plus or minus 22 over 12. All right, now what I do is exactly like I did when solving the power equations or the quadratic taking the square root. When I get the plus minus, it's important to realize this plus or minus are two different expressions. So I'm going to split those up now. I'm going to say x equals negative 2 plus 22 over 12. And then x equals negative 2 minus 22 over 12. And all I need to do now are simplify the numerators and then reduce anything that needs to be reduced. Negative 2 plus 22 is a 20 over 12. I cancel a factor of 4 between those to get that x equals 5/3. Again, 20 divided by 4 is 5. 12 divided by 4 is 3. That's one solution. My other solution comes from over here. Negative 2 minus 22 is a negative 24 over 12. And I can reduce that all the way down to negative 22 divided by 12 is negative 2. And so there we have it. As expected, I have two unique solutions. Important to remember that a quadratic can have two unique solutions. I usually expect it. It can have one or no solutions, or what we call complex solutions. To step back now for one last thought is the A, B, and C in this formula don't involve x's. They're just the coefficients. The A is the lead coefficient, B is the linear coefficient, and C is the constant coefficient. When I identify that 6, that 2, and that negative 20, I plug them into the formula. My job is to first simplify this stuff inside the square root. By the way, we call that a discriminant. We give it a name because it determines the types and number of solutions that we get. But I simplify that first. If I can nicely, I take the square root, and then I'm to something right here. To find my two unique solutions, I need to separate that into two different expressions and simplify them as much as possible.